how I didn't hit record on that, I do not know. So just to summarize, I moved sine x to the other side, replaced cosine x with its, good morning, with its half angle formula replacement, and then to get rid of the radical, I squared both sides. Okay, so I'm going to put this over 1. If I cross multiply, I get 2 sine x, and I'm just going to put the square on it like that, equals 1 plus cosine x. Okay, now, we didn't get beyond this, did we? So we've got to try to figure out how we're going to solve this. We've got a square here. What if I go, when I see a square on a trig function, what could I do with it? Where could I go, Caleb?
Oh, no, to the theorem.
Yeah, go to your theorems, your Pythagorean theorems, because there's one of the Pythagorean theorems, and I'm going to have to put something here so I can flip. Sine squared x plus cosine squared x is 1, right? I'm going to come over here and I'm going to work sine squared plus cosine squared is equal to 1, right? So, though that's a little sloppy up there, I'm going to kind of readjust some stuff. I want to replace sine squared with cosine squared just so I can get everything in the same. I'm thinking here that what we're going to end up doing is factoring this to solve it, because that's the only thing I know to do when I got a square, except for the quadratic formula, which I don't want to do with all this messy trig stuff. That would be painful, you know. So I'm thinking, let's replace this sine x squared. Let's replace it with whatever it's equal to in terms of cosine. If I have the identity up here and I'm kind of messing around with it, couldn't I subtract cosine squared from each side? And I would have sine squared is 1 minus cosine squared, right? So this is what I do a lot. If I see something and I know that I could replace it, like I'm seeing I've got sines and cosines kind of stuck, so I'm thinking, let me turn everything into cosines and see if maybe I could factor it to solve it. So a lot of times I write the identity here just so I can move the terms around, just so I'm not trying to do so much in my head, and because already we kind of get a little freaked out when we see these sort of things. So if there's the 2, right? It was there in front of the sine squared x. I'm going to replace sine squared x with 1 minus cosine squared x. And I'm just going to copy the other side down. Okay, so now I got all cosines. That's kind of a good thing. So let's see now if we can't get everything on one side and simplified. Before I move it on one side, let me do the distributing on the left-hand side. 2 times 1 is 2. 2 times negative cosine squared x would be negative 2 cosine squared x equal 1 plus cosine x. Now, I want all my terms on one side, and I really want a positive square term, because do you remember when we're factoring, like if I had negative x squared minus 5x minus 6, that's kind of a mess, isn't it? So I want a positive square term. So what I'm going to do, instead of moving everything to the left, I'm just going to move everything to the right, because when I do, it'll turn that square term positive. Because if I've got minus 2 cosine squared x, to get to the other side, I'd say plus 2 cosine squared x. Okay. And while I'm at it, let me go ahead and move the 2 over also. And I'll have 0 on the left-hand side, so I'm going to subtract 2 from each side also. I'm just moving both terms to the other side. Okay. Now, that's 0, so they really all add up to 0. And if I put things in terms like standard form, where you put the square first, and then you put the next term down, then you put your constants last, wouldn't I have 2 cosine squared x plus cosine x, and then 1 minus 2 would be negative 1, right? Okay, so what I'm going to try to do now is go factor that and solve it, because we were supposed to solve this, and we're still not there. All we've done is mess around with it algebraically and substitute a few things. Okay, so 2 cosine squared plus 2 cosine squared x plus cosine x minus 1, is that right? Okay, thanks. Okay, so now I can start trying to look at factoring it. If you don't like looking at cosine squared x in there, you could replace it with maybe a u and have 2u squared plus u minus 1. That's what some people do. But if it doesn't bother you too much, you could say, okay, it's a square. If I factor it, I know that to get 2 cosine squared x, I'm going to have 2 cosine x and cosine x, because 2 times 1 is 2, and there's no other way to get it, right? And I'm not going to write the invisible 1 out in front of the cosine x, just because you can if you want to. And if I'm going to get a negative 1 for the constant term down here, right here, it's either going to have to be, it's going to be plus 1 and minus 1. Either way, it's going to be 1 times 1. And now I just have to kind of mess with the signs to see what would work out to give me a positive cosine x, a positive 1 cosine x in the middle, and a negative 1 on the end. If I want a positive cosine x, if you remember, my middle term comes from multiplying these two together and these two together. If I want a positive cosine x, shouldn't I have a plus 2 and a minus 1, right? Okay. So it would factor this way. All this stuff is stuff you learned back in algebra that's now, you really see how you have to have it to kind of move on. A lot of students think they can just like not worry about this and it'll go away, but it doesn't. So now I have 2 things to solve, right? When 2 things multiply to give me 0, either the first factor 0 and or the second factor 0. Okay, so we got two things to solve, and so that's going to give us all of our answers here. So let me move 1 to the other side. Be 2 cosine x is 1. And let's divide by 2. Okay, cosine x is 1/2. I'm going to use this slide to work on this one, then we'll work on the other one on another slide because I'm going to be out of room here. What has a cosine of 1/2? The sine of 30 is 1/2.
Cosine of 60, right?
I think cosine, yeah, let's see. Sine of 30 is 1/2, so cosine of 60 is 1/2. Yeah, so it's 60 degrees, which, let's put it in radians. 60 is pi divided by 3, right? Okay, because 180 divided by 3 is 60. I'm just going to put 60-degree reference angle just in case just so it'll be on the video. And that's pi over 3. Now, it's a positive 1/2, right? How many angles have positive 1/2 in one trip around the unit circle? Because I don't know if you remember, at the very beginning they did this. They said just give the solutions in this interval. Yeah, so let's see, let's write all students take calculus. So it's positive in the first quadrant and in the fourth quadrant. How would I find this 60-degree reference angle right here in the fourth quadrant?
2 pi minus pi 3.
2 pi minus pi 3, pi over 3. And if I get a common denominator of 3, if I multiply 2 pi times 3 over 3, that would be 6 pi over 3 minus 1 pi over 3 would be 5 pi over 3. So my answers for that one are pi over 3 and 5 pi over 3. So that's the answers for that factor. But we still have another factor to mess with. Now turn this on. If you think about solving the other one, if I subtract 1 from each side, I get cosine x is negative 1. Where on the unit circle do we have a value of negative 1 for our x coordinates, since cosine represents x on the unit circle? Pi, So it's only going to be pi, isn't it? We only have that one solution from this one. So my other solution, without going to another, is pi. So my solutions are pi thirds, 5 pi over 3, and pi. So we got 3 solutions out of that problem. There's a lot in there, wasn't there? But a lot of it was just kind of following along, and the trick to me was seeing that when you had, once you got you rewrote that half angle, you went to get the half angle formula, and you ended up with a sine and a cosine and you're trying to solve it, and it's kind of hard to solve something when you got both trig functions in there. So try to get it to one trig function when you have something like that happen. And then a lot of times what's going to happen is you're going to end up factoring or something like that. Something will happen. Either something's going to cancel out or you end up factoring to solve it.